So, very good morning, dear students. As we were doing the chapter Principle of Mathematical Induction, and in the first part, I have explained you all the basic things about it, and I guess we have taken two questions of it. Now, in this video, we'll be going to see some of the questions related to the same, okay, and I'll solve your doubts, whatever your doubts are, okay. As I have given you this question to do, that is 1 into 2 plus 2 into 3 plus 3 into 4. Some of you are having this confusion that is this decimal or is this a multiple. Okay, so let me clear you one thing. How can you just distinguish between like this is a decimal or a multiple? So you do one thing, you just check P1. What is P1? P1 gives the value for n equal to 1 in this one. If you put n equal to 1 in this RHS, that is 1 bracket 1 plus 1 bracket 1 plus 2 upon 3. You got 1 into 2 into 3 upon 3. 3 to 3, 1 into 2, that is what? 2. So 1 into 2 is what? 2. Now you go for P2. If your answer is coming, that answer, that means this is 2 plus 3, 6. Your answer should come 8. Then you confirm from there that this is a decimal thing. This is how you can, and it is in this chapter, there won't be any like decimal thing. It will be multiplication only. Else, if you want to be double confirm, you just go use this method. Okay. So we are starting the solution from here, and P1 we got 1 into 2, 2, which is true. You can go for P2 also. It's not required to find P2 also, but you can check. That's not an issue. So for n equal to 1, it is true. Okay. Let it is true for Pm, that is n equal to m. So what will be Pm? Pm will be 1 into 2 plus 2 into 3 and so on up to m bracket m plus 1 equal to m plus 1, m plus 2 upon 3. Alright. Now, for n equal to m plus 1, what will be the case? That is Pm plus 1 is 1 into 2 plus 2 into 3 plus 3 into 4 and so on up to m. In place of this n, we are writing n plus 1 and m plus 1 equal to, what will be this? M plus 1, then m plus 1 and m plus 1 plus 2 whole divided by 3. So this is nothing but m plus 1 and m plus 2, and this is what? M plus 1, m plus 2, m plus 3 upon 3. Now what we do, we take LHS. So taking LHS, okay, how can we write this LHS? 1 into 2 plus 2 into 3 plus, this is m plus 1, m plus 2. I explained you what will be the preceding value of it. So you always remember the preceding value will be always this one. Okay. So the preceding value is m plus 1 plus this. So in place of this step, what can we write? m plus 1, m plus 2 upon 3. So just write it. In place of this step, we are writing this m plus 1, m plus 2 upon 3 plus this m plus 1 and m plus 2. Now as you can see that m plus 1, m plus 2 and m plus 1, m plus 2 you can take common. So m plus 1, m plus 2, in the bracket you are left with m upon 3 plus 1. So what did you get? Take the LCM. So it will be m plus 1, m plus 2, m plus 3 whole divided by 3. Are they equal? If they are equal, then at last you have to write, hence this is proved by the mathematical induction. Okay. Okay, let us consider this question. It says 3x plus 6x plus 9x and so on up to n terms is equal to 3 upon 2 n plus 1 x. So whenever you get this question where it is going up to n terms, where you don't have the nth term, you need to find it. Okay, so I have found it in the further steps. So this should be in the front. So I mean this should be in the front, because first you need to find what will be the nth term of the series. So as the series is in AP, so we can use an formula, that is a plus n minus 1 into d. So a is what, 3x, n minus 1, and the common difference is 6x minus 3x is 3x. So on solving we got 3nx. So what will be our nth term? This is 3nx. Now comes, let the statement be Pn. For n equal to 1, P1 will be what? On putting the value 3 upon 2, 1 plus 1x, you got 3x. So it is true for n equal to 1. Then comes, so Pn will be our, this one, 3x plus 6x plus 9x and 3nx is equal to this. Now let it is true for n equal to m. So what will be your Pm? Replacing m, replacing n and putting m. So here is the equation. For n equal to m plus 1, so Pm plus 1, 3x plus 6x plus, in place of m we are writing m plus 1, so x, and 3 upon 2 m, for in place of n, m plus 1, and n, m plus 1 plus 1 x. Okay, this step can be written as this. How? 3x plus 6x. Now what we will do, we will see the preceding value of this. So what will be the preceding value of this? I told you it is directly 3mx you can write from here, and this step is equal to this. Now taking LHS, we are going to take this LHS step. So we know that this full is what, here 3 upon 2 m plus 1 into x plus this 3 times of m plus 1 into x. Okay, from these two you can take 3 m plus 1 x common. So taking 3 m plus 1 x common, we got m by 2 plus 1. Now take LCM, this will be m plus 2 upon 2, and that can be written as 3 upon 2 m plus 1 m plus 2 x, and as these two are equal, hence proved. Okay. Okay, let us come to the different question. You are given with 1 into 2 plus 2 into 2 square plus 3 into 2 cube plus so on up to n into 2 to the power n is equal to n minus 1 into 2 to the power n plus 1 plus 2. You have to prove this by the principle of mathematical induction. So I'm not solving the very first step like solving for p equal n equal to 1, then it is always true for all the questions. Okay, so I'm not writing that you can understand. Okay, I'm directly taking for n equal to m, putting m in place of n like this. For n equal to m plus 1, what will be m plus 1? 1 into 2, then 2 into 2 square plus in place of this n, m plus 1, 2 to the power m plus 1 equal to n minus 1. So in place of n we are writing m plus 1 minus 1 into 2 to the power m plus 1 plus 1 plus 2. Now this step can be written as this. How? This is as it is, this is as it is, plus what is the preceding step? The preceding step is nothing but this one, as I told you, plus this is as it is equal to, here we can cancel this 1 1, you are left with m, 2 to the power m plus 2 plus 2. Now taking LHS, that means we are going to take this step. Now in this step, this is we already have, what is this? M minus 1, 2 to the power m plus 1 plus 2. So we are writing here, this step is written here in place of this one, and here m plus 1, 2m plus 1. Now from here to here, what I did, I have taken these two closer here and plus 2 here. Why? Because I can take 2 to the power m plus 1 common. So I've taken 2 to the power m plus 1 common. We are left with m minus 1 and m plus 1. This 1 to 1 you can easily cancel. M plus m will give you 2m and plus 2 as it is. So here 2m plus 1, 2 to the power 1 into m plus 2. This a to the power m into a to the power n is a to the power m plus 1, and the law of that is indices. Okay, so 2 to the power m plus 2 and this m here plus 2. See this and this, they are proved. So hence proved. Okay. Again, the same thing we are going to do. You are given with 1 minus half into 1 minus 1, 1 upon 3 minus 1 upon, into 1 upon 1 by 4 and so on up to 1 minus 1 upon n plus 1 equal to 1 upon n plus 1. We have to prove this statement. So for n equal to 1, 2, that I'm not proving. I'm directly starting from n equal to m and n equal to m plus 1. This is for n equal to m and this is for n equal to m plus m. Taking LHS of this m plus 1. Okay, so we know this step can be written as like this. How? This is as it is, this is as it is. Preceding step of the preceding value of this will be here, so I have written here, and this is as it is. In place of this step we can write 1 upon m plus 1, and here this as it is. Now take the now take LCM. M plus 2 minus 1 upon m plus 2. This is m plus 1. This m plus 1 and m plus 1, they are cancelled, and we are left with 1 upon m plus 2. This is how we proved. Okay. Okay, let us consider this question. This is an example. Okay, some of you are having problem in this question, so I'm taking this question. So for 1, 2 and all that you can do, it will be always true. I'm taking from n equal to m. This is the question. For n equal to m, this will be for n equal to m. For n equal to m plus 1, in every n you have to write m plus 1. So m plus 1, m plus 1. M plus 1 plus 1 will give you n plus 2 upon 2 the whole square. Taking LHS, this step can be written as this: 1 cube plus 2 cube plus, what will be the preceding step? This m cube, okay, and m plus 1 the whole cube. Now in place of this step, you can write this one. So m plus 1 upon 2 the whole square plus m plus 1 the whole cube. Now don't make it complicated by applying a plus b the whole cube identity here and here also. Okay, you will be very confused. You just see what you want to prove. You have to prove this now. So you need m plus 1 common and m plus 2. Whatever you are getting common in this, you just take out. So this is whole square. So actually this is m square, m plus 1 whole square upon 2 square. So you can take m plus 1 cube you are having here and m plus 1 whole square here. So you can take m plus 1 the whole square common. Alright. So you will get here m square and 2 square is 4. Plus here 1 m plus 1 will be there. Okay. Now take LCM. This will be m square plus 4m plus 4 upon 4. This is an identity of m plus 2 the whole square. So m plus 1 the whole square, m plus 2 the whole square upon 4. Now they all can be written as m plus 1 into m plus 2 upon 2 the whole square. That is how it is proved. Okay, let us take this question. This is the question and we need to prove by the principle of mathematical induction. For directly I'm taking for n equal to m. This will be for n equal to m, and for n equal to m plus 1, this will be for n equal to m plus 1. Here if you put m plus 1, so 2 times of m plus 1. So 2 times of m plus 1 and plus 1. So I have solved it. This will be 2m plus 2 plus 1 or 2m plus 3. Okay, so 2m plus 3, and this will be 2m plus 5. You just see it. Okay, I've directly written. Then here in the RHS, m plus 1 upon 3, and here also m plus 1, so 2m plus 2 plus 3, so 2m plus 5. Okay, taking LHS, I've taken LHS, and as of I'm explaining you from the 4 to 5 question previously, that this step can be written as this and that. So I'm directly taking, I have to add this thing and this thing. I hope you will understand how this plus this. So I have written, because this step can be written as writing the preceding step will get this same step, and in place of that step we are writing this. So directly we can write, no, okay, this plus this one. Okay, so in these two you can take 1 upon 2m plus 3 common. So 1 upon 2m plus 3 I've taken common. You are left with m upon 3 plus 1 upon 2m plus 5. Now what you can do, take the LCM. 2m plus 5 when multiplied by m, you will get 2m square plus 5m, and 3 into 1 3 whole upon 3 into 2m plus 5. Now this is a quadratic equation. On splitting you will get these two factors. Now you know how to do it, so I have not mentioned here. From here to here we can directly write. So what will happen, this 2m plus 3 will be cancelled with this 2m plus 3, and you are left with m plus 1 upon 3 times of 2m plus 5, and which is the required proof. Okay, so that's it for today. In the next video, we'll see some the other kind of questions, and then we'll wrap this chapter up. So till that, do the practice. Thank you so much. Have a nice day.